Systems of linear inequalities. It's kind of taken things all the way back around. So if we start with kind of like what are these systems and so on. So if we have systems, they're pretty much just two or more. So I'm going to write 2 plus linear inequalities. So systems of linear inequalities are we really just have two of them. So we started out this chapter doing like systems of linear equations. And for that, I don't know if I'd write this. But when we did those, we had two different lines, two different nice, perfectly straight lines like mine there. And the solution was going to be that point, that intersection. What's the one point that works for both this line equation and this line equation? Well, now what we're going to have is it's going to be, instead of just being lines, we're going to have maybe something that first one was shaded like this, the second one then is going to be shaded perhaps like this. So the system is going to be what part, or the solution I should say, is going to be what part is included in both of those, which part is shaded twice, and possibly some boundary lines as well. But that's kind of where we're going, so let's actually go there. So graphing them, threw a couple steps in there, and really the first step is kind of just saying like what we did in section 5. Do what you did there, but we're going to do it twice in a row. So if we do this, for example 1, so graph each inequality and lightly shade. So my first one here, that is going to have a y-intercept of positive 4, that's the plus 4. Put a dot there. And then my slope is going to be the 3, which we know if we're doing rise over run is 3 over 1. So I start at my y-intercept and I go up 3 and over 1, that gets me right there. And now I'm off the graph. So again, rise over run, we have rise of 3, run of 1, both positive. You could do the same thing going negative 3 over negative 1. So I could get some more points going down 3 over 1, down 3 over 1, and so on. So I'm going to do those. Down 3 over 1, down 3 over 1. So I have a bunch of points that makes it easier to be accurate. We're going to put a straight edge on there and put a line through it, but because it's y is less than, we have this less than sign right there. It needs to be a dashed boundary line. We went over that in the notes yesterday, and you maybe had it last year also. But because it's less than, not less than or equal to it, our solution isn't going to include the boundary line. So we do one of these dashed lines to kind of show it's going to be everything on one side of this line, but not that line itself. Alright, now we need to figure out which side to shade. So I usually put in the origin. So I'm going to show my work up here. I have y is less than 3x plus 4. And you could put in any point as long as that point's not on the line. I'm going to put in my zeros here, 0, 0. So 3 times 0 plus 4. The reason I like that is now 3 times 0 just drops out, and we have 0 is less than 4. So once we simplify it as much as you can, you look and say, is it true? Yes, 0 is less than 4. So we know then that that point, the origin, works. So we shade everything on that side. So I'd encourage you to kind of just lightly shade. I like doing my shading about perpendicular to the boundary line. So if you have multiple things, you can tell, all right, so these lines go with that. That's my first one. I'll switch colors and we'll do this second one a minute. So now we just kind of repeat the same process with the second line. Y-intercept is right there, it's a positive 1. Slope is going to be negative 2 over 1. So I start at my y-intercept, I go down 2 for that negative 2, a run of 1, put a dot, down 2 over 1, put a dot, and so on. So I'm going to do some of those. And once you get to the end, you could always go back and go the opposite direction. It'll help you be a little bit more accurate. So up to left 1. So now I have a whole bunch of dots that boundary line is going to go through. It's a greater than or equal to. The or equal to means we do a solid line. Get my straight edge on there. And do, touching it with more than one hand. There we go. So I do, there we go. So I have my boundary line drawn in. So I can touch that up a little bit, get a little bit of that. Now we figure out which side to shade. It's close to the origin. If I'm not sure, I'll pick a point different than the origin. In this case, I could use the origin, but I'm maybe going to put in, why don't we put in this point here, 1, 2, 3. So I'm going to put in the point 3, 0 and see if that works. So I put a 0 in for y. 2 times my x value is 3. So I get 0 is greater than or equal to negative 6 plus 1. Looking good so far. 0 is greater than or equal to negative 5. So is that true? Yep, it's true. So we shade the side that has that point on it. If it had been false, then we'd shade the other side. So I have that. Now, final thing, we can finally move on to step number 2 up here at this top part. So we need to look at, well, what was shaded twice? This part here is shaded both with the blue and with the green. So my final answer then is going to be kind of right up to this blue line, because it's dashed, and down to that green line, including the green line. This part here gets shaded twice. So that's example 1. Most of the ones you see are going to look just like that, and just kind of crank through those. But we will throw some story problems at you also. So I just kind of do the quick mention on the story problems. And I'll try to go a little quicker through this thing here. But Ed has a mowing job, or a job mowing and raking lawns. In 1 week he can do at most 9 mowing jobs or 7 raking jobs. So Ed charges $20 to mow, $10 to rake, wants to earn more than $125 each week. Show all the possible combinations. Now, if we're looking at domain and range, really we probably should have our final graph being dots. Because if he mows half my lawn, I'm not going to pay him. But we're going to just shade in like what would possibly work here for our friend Ed. All right, you'll notice the graph. I have my x-axis down here, y-axis there, because he can't really do a negative number of lawns for mowing or for raking. And I'm going to put my mowing over here, so mow and rake, capital R for rake. And if we were to go through and do these, I'm going to say $20 to mow. So we could do 20M plus $10 to rake, 10R. He wants to earn more than $125 each week. So if it was at least 125, it'd be greater than or equal to. More than is just going to be the greater than. So we'd have this right there. So we could figure out what's that going to look like. So if I were to do my x-intercept, I could put a 0 in for r. So 20 times m plus 0 is greater than 125. And that'll give me 6.25. So we could do really 7 lawns, but we'll say 6.25 mowing jobs to get the $125. Or we could say, well, what would it be if you just were to do all raking? And then we'd get a 12.5 there. So we need to have our axes go up to at least those numbers. So let's see what I have to work with here. If we were to say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ooh, I did it about right. Okay, so then we'll say 0 down here, and maybe 2, 4, 6, 8, 10. Put in like a 4 maybe. And then mowing, we might as well just go up by 1s there also. So we have 2, 4, 6, 8, 10. And we could graph our line. So we know the intercepts, so over 6.25. Maybe I'll take and switch this. So this thing here is going to be in blue. And so I have 6.25 is going to be right about there. And over 0 up 12.5, so that's going to be right about, right now, 4, 6. I missed a line. Shoot. So this should be 8. This would be 10. This would be 12. Let's see if I can erase that little 10. There we go. Okay, so 12.5 then in blue is going to be right about there. And because it's greater than, I do a dash boundary line. So I'm going to do this here. And again, we don't have anything in the negatives because you can't really do a negative number of raking or mowing jobs. And greater than, we could pick a point, you could put in the origin, but I'm going to try to save a little time and say we're going to have to shade this way if it's greater than. But it looks like we're done, but if you go back to that very beginning part, in a week he can do at most 9 mowing jobs. So mowing, the most he can do is going to be 9. And when we have that then, that's going to end up being a vertical because he can't get to the 10. So this one's going to be kind of like shaded this way. So you could do 9 or fewer mowing jobs. then 7 or fewer raking jobs. Let me switch to my yellow. So there's 7 raking jobs, and that's the at most. So we have 4, 6, 7. So that'll be a horizontal line. So you could do at most that much. So our final answer then has to be now the part that's shaded 3 times in there. So let me go for red so it'll show up. So I need to be larger than the blue, but below the yellow and below the green. So something like that, that little shaded region is going to be the possible combinations. And realistically, what we really should do is it should be a graph of dots. So we should go through there and put a dot at every one of those. But we're not going to get quite that sadistic in this section. All right, so that's that one. I want to just quick look at a couple special cases, and then we are done. So if we have parallel lines, I'm going to go real fast. So I know the notes are kind of dragging. But if you were to get a system where you have parallel lines, that top one we shade up, this bottom one we shade down, and you say, well, how many parts, what's shaded twice? This one is going to have no solutions. So that would be no solutions for that one. Put my notes, see what I want to do here. Right, so B, if that top line was shaded down, and that bottom line then were shaded up, well, the solution is going to be everything in the middle, because that middle stuff was shaded in blue and shaded in green. So I would just shade it in like that and kind of have the red be, I could do the solution, is that stuff there in the middle. And final answer then would be C, the other possible combination. If the top one were shaded down like in B, but then the bottom one was also shaded down, now the part that's shaded twice is going to be the stuff that's below that bottom line. So if I slide that up. So final answer, the stuff that's shaded twice then would be everything below that line, because that's shaded twice, so the solution. And that would keep going kind of off down there. So that's it for the chapter. Let me know if you have questions. Thanks for watching.